the data which we are having is distributed to multiple machines, right? It's like multiple disks.
Yeah, yeah,
As you see here, we have the bunch of disks available, right? So means disk 1, disk 2, disk 3. So multiple disks are available. So what we are doing, first we are distributing the data to this bunch of disks. After that, we are processing the data, right? So generally, when we buy a new computer or a new machine, what is the first thing we do? We have to install the operating system,
Hadoop
right?
system.
OS. Without OS,
Yeah,
we won't do anything, right? So it's a new
yeah,
machine. You buy a new computer. The first thing is you have to get the machine. Then if you have to install the OS, operating system. So now here generally you can install Linux or the different kinds of Windows. But
yeah,
preferably for the Hadoop, we use the Linux file system,
yeah.
right? So it's a new computer, so I have installed the Linux. So when we install the Linux, what we get, we'll get the Linux file system. What is the
Yeah.
Linux file system? See here, when we install the Windows, this is a Windows file system, right? The programming
Mhm.
documents, downloads, right? C drive, program files, system 32, Windows directory, it's a Windows file system. The same way, when we install the Linux, we'll get the Linux file system. We call this Linux file system as also local file system. Okay, we call it is also local file system, right? So once we configure with the OS, then we can install any software in that machine, right?
Mhm.
So now what I did, so I need to work with the Hadoop, so I have to install the Hadoop. So then what I did, so I took a Linux terminal, then I have started installation of the Hadoop. So when we
Hadoop.
install the Hadoop, Hadoop will give you the another file system. So it's the same computer, same disk. So I install the Hadoop. So when we install the Hadoop, Hadoop will give you another file system. So we call this file system as a Hadoop file system or SDFS file system. Okay, so what we call it as a Hadoop file system or SDFS,
Hadoop file system.
Hadoop distributed file system.
File system.
Now see here, in a same disk, we have the two file systems are available. One is a Linux file system and other one is a SDFS file system. So it's a one computer or one disk. We have the two file systems are available. Now, so what we do in SDFS, SDFS is to a file system which contains the data to be processed, right? So what is the data you have to process? Your client data, your business data, or the Hadoop big data, whatever you are going to process, that data you must make available in a SDFS. So here when we are working, so very the new people may have a bit confusion here. Why? Because where we are installing Hadoop, we are installing Hadoop in a Linux.
Linux.
So that is, where do you find the Hadoop installation files? In a Linux file system, right?
Mhm.
So Hadoop installation files are available in a Linux file system or the local file system. So the local file
Mhm.
system contains the Hadoop installation files
Mhm.
and Hadoop configuration files, right? So Hadoop binary files. So everything available in a local file system. So you install Hive, if you install a pig or if you install some Python, whatever you install, everything is going to be installed in a Linux. So if you install a Spark, everything is available in a Linux file system.
Linux.
So if you want to change any configurations, you have to connect to the Linux file system to make the changes, because all
Okay.
the installation kind of properties are available in a Linux file system. So if you want to start work with the Hive, then you have to connect to the Linux file system, go to the directory where you have the Spark. From that you have to start the Spark, right? So that is
Mhm.
the
Mhm.
importance of the local file system. Then what SDFS file system contains? It contains the data to be processed. Only the input data that is available in a SDFS. Apart from that, SDFS doesn't store anything. So it contains data to be processed.
So data to be processed, like if we are trying to get data from, suppose some file may be text file or maybe DAT
Yes,
file or
yes,
something.
yes.
So that file will be stored in SDFS.
SDFS, right? So it's related to your client data. You may are getting the data from the production database, or you're getting the data from server, right? The data which actually have to work in the Hadoop, that data.
Okay. And but the Hadoop SDFS file system is under the Linux file system, right? Local file
Yeah,
system.
on top of the same disk, we have the two file systems.
Oh, yeah. Okay. On the top of the Linux, there is a SDFS file system, right?
Yes, correct.
Okay.
And we can also copy the data from the local to SDFS
SDFS.
as well as SDFS to local. We have an option, so we
Local.
can able to
Okay.
copy the data from one file system to another file
Mhm.
system.
So whether we can copy that the data, the file which has a data and store in SDFS, we can copy that file into local file system, and from there we can also process it.
Yes, sometimes you have the data in the Linux machine to
Mhm.
work with the data which is in the Linux, right? So you can copy those files to SDFS and you can process the data. You have the data available in SDFS and now you want to take the backup, then get it to the
Okay.
Linux file system.
And whether we can work with both SDFS and Linux, some file in SDFS and some file in Linux local file system, we can use both files as a processed for processing purpose,
No, no,
as a input.
no.
Okay.
Let me correct you. So you cannot use the local file system files to be processed in Hadoop because
Okay.
Hadoop jobs are MapReduce jobs. Hadoop jobs are it's a different thing. So the Hadoop jobs are performed when the data available in SDFS. So generally we
Okay.
don't because Linux is a standby machine. So
Mhm.
your data must be in a SDFS.
Okay. But for the backup point of view, we can make a copy of
Local file.
the file, yeah, to put into the local file system. Okay.
Yes.
But processing will be performed only in a SDFS.
Yes.
Okay.
Okay. So this is like one disk. But when we are working on Hadoop in a production, right? So what
Yeah.
we have multiple disks are there, right? Something like disk one, right? So we'll get the like this disk one, then disk two, disk three, disk four. Then the sysadmin will configure each disk as a node. That means a node may contain one disk or a two disks, right? So now we call it as a nodes,
Mhm.
right? So now we represent this. These are the machines, are the computers where you have the disks. We represent these machines as a nodes, and the network admin will establish a connection between all these machines. Right? All the data nodes are connected to a another node. It's we call it as a master. We'll touch that point right later. So now this is
Yeah.
node 1, node 2, node 3, node 4. So as I told that in every node we have the disks. In every disk we have the two file
Local
systems.
file system or yeah,
Yeah, we have the
local and
two, correct,
SDFS.
right, two file systems available. So now this is the local file system and this is the Hadoop file system, right? So now, right, what I want to do now here, the client or the developer or you want to you have a some file available. The file name is prodinfo.txt. So we have a some input data. The file contains prod underscore info dot csv file. Okay, so I got a one requirement. What I need to know, I need to take this file and I have to copy this data to the Hadoop cluster SDFS and then have to count number of products. So this is the job, that this is the program which you have to write. So what you have to do, so you have to count the number of products in a file prod underscore info dot csv.
Mhm.
Okay, so now you have to do these two things. First one is you have to make the data available in SDFS, then you have to write the
Mhm.
program to count, right? Two jobs are there. One thing is
Mhm.
you have to copy the data, then you
Mhm.
have to perform count. So what I'll do now, first I have to copy the data to the SDFS file system, right? As I told, always we should make the data available in SDFS. So
SDFS.
yes, so I use a simple command, put command, and I want to copy the file prod underscore info dot csv. I want to copy this file to the directory
SD.
Amit, right? In a directory
Okay.
Amit right, under the
In
subdirectory.
SDFS.
Yeah,
In SDFS.
in SDFs, correct. Under the Amit directory, so the subdirectory pra. So I want to copy these files to this place, right? So yes, I can run a put command to copy this file. Like this, I'm copying multiple files, one file, two file, three files. So I'm copying hundreds of files. Then after some day, how do you reference each individual file? How do you identify which files are available in the which directory? It's a difficult, right?
Yep.
All right. So now what we are doing here, Amit, we are copying the data, this file system, right? We are copying the data to this SDFS file system. So these are the machines. These are the nodes where input data is available. The data which we are going to process Hadoop cluster is available in these nodes or this machine. So that we call these machines are the data nodes, right? So we call these machines are the data nodes. So now what data node contains? The data node contains data in where? SDFS
SDFS.
file system. Data nodes contains data in SDFS file system. Now what I'm doing, I'm keep writing the data to these data nodes. So after some time, after some days, you may have so much data, so references will be difficult. Like you have a textbook of 1 lakh pages, and I told you to find a paragraph, right? Not a chapter. I told you to find a paragraph. Is it possible, Amit? Possible,
No.
possible, but it takes a lot of time,
Yep.
right? So it's, you can go with a sequential order or you can go with a random order, but it takes a lot of time, but I can able to locate, but it takes a lot of time. But if you have an index is available, then it's
Yeah,
very
it
easy
will
for
be
me to look.
fast.
Correct.
Yeah.
So the same way, so what I am doing here, I am taking one more node, right? So
Mm-hmm.
where in this node, what I am writing, I am writing the index of the data which I am going to write in the data nodes. Okay, so that I'm
Mm-hmm.
calling this node as a name node. Okay, so now what
Mm-hmm.
name node contains? So all these data nodes are connected to this name node, right? All these slave machines as a slave
Mm-hmm.
machines connected to the as a master node name node. So now what name node contains here? The name node contains,
The index and the file name.
yeah, index of the data in the data nodes, right? Index of the data in a data nodes, or you can say the reference of the data in data nodes. So that is written into the
So,
name node.
so if reference of the data, like
Yeah,
data is a file,
I'll,
like example prodinfo.csv, right?
just a second, Amit, we'll tell you. So now what is the index of the data? So now it will write like this, prod underscore info dot csv. First it will write the file name.
Hmm.
Okay.
Okay.
And what is the file size? 1000 MB.
Mm-hmm.
Okay. So what is the replication factor? We'll tell you what is the replication factor later. So what is the block size in the Hadoop cluster? Some block size. What is the replication factor? Some 3. Who created this file? Amit. He belongs to which group? Dev group. And what are the privileges to this file? RWX, RWX. So this particular line is written to the name node. For every file, this one, this particular path or information about the meta file, meta information about the file written to the name node,
Okay.
right? So now you got what name node contains,
The
right?
yeah.
These things: file name, file size, the block size, replication factor, who created, belongs to which group, what the privilege. So every file you are writing here, that file reference is written into the name node,
Mhm.
right? So now you understood what name node contains and
Yeah.
what data node contains. Okay,
Mm-hmm.
right? So till now any confusion? No confusion, correct,
Mm-hmm.
Amit?
Yeah, no confusion.
Right. Okay, so now what I'm doing here, I'm trying to copy the data. So which data? Prod underscore info dot csv. As I told that the data is going to be distributed, right? It
Yeah.
is a distributed data. Then how the data is going to be distributed? See, generally this file size is 1000 MB file size. Okay, consider the file size is 1000 MB, like a 1 GB file. So
Mm-hmm.
now when I'm trying to write the data, so the data is going to be distributed. That means the input data is divided as a
into multiple.
small size of chunks, right? So we call small as a blocks. We call the small size chunks as a blocks. The input data is written as a small size of chunks as a blocks. Then what is the next question here? When I said small size means how much? Correct? Small size means how much? So how much means when you first configure the Hadoop cluster, alright, when you install the Hadoop cluster, we'll have a Hadoop configuration file with the name hdf-cited.xml. So this comes with the Hadoop installation, right? So in this configuration file, hdf-cited.xml, in this file we have a property, so that is a dfs.block. For this property, generally you can specify 64 MB, or you can specify 128 MB, or you can specify 256 MB, or you can specify 512 MB. So which one you specify, that is going to be the default one. Suppose consider, to make the mathematics simple, I am taking 64 MB. That is every block size is how much? 64 MB. I am using for my Hadoop cluster, but right now we are using 128. Okay, so in the new versions we are using 128 and 256. Within the world we use to 64 MB. So now what is the property you specify here? So that is going to be the block size. So now see here, what is the file size? 1000 MB. What is the block size? 64 MB. So how many blocks it will create? It will create 15.6. That is total 16 blocks are created.
So 16 blocks. So what is differences is like, what is the block? Because 1,000 is a file size.
1000
So
MB is the file size.
so each node, like each data node will have a file of 1000 MB. So what is what is the block in each node?
No, it's something like, suppose this prod underscore info.csv contains 1 to 1 lakh rows. Okay, so then you're dividing this 1 GB file as multiple blocks. So block 1 contains some 10,000 rows, again block 2 16 blocks, right? So each block contains some 10,000 rows, not 5,000 rows, something it will contain, right? 1 to 5,400 rows are in block 1. Then next remaining 5,600 some blocks are in the second block 2. That means the total 1 lakh rows are equally written into all the 16 blocks.
Okay.
That is, the
And
input data is divided, right?
yeah, so yeah, each block have a number of rows.
Yes, yeah, the data in this file, whatever the data are in this file, so that data is available in this block.
Okay.
Okay, so that is, this is the actually the file is brought in CSV. See here, so 16 blocks, like you can see block 1, then block 2, right? So like 16 blocks are going to be created. So when you like 16 blocks, that is the total, the complete data is a combination of block
Blocks.
1, yeah, block 1 to block 16, because block 1 is some part of the data, block 2 will have
Yep.
some portion of the data, block 3, like, so that total data means if you want to read a complete file of the product info, you have to read block 1 to block 16,
16.
right?
Yeah.
So this is how the data is divided as a blocks. Now see, as you remember I told, so we are using the commodity hardware. What is the, we are using the reusable machines, right? So that is the data which we are going to use in the Hadoop cluster. Maybe it may goes down, right? We are buying inexpensive storage machines to process the data, correct? So that is, I wrote block 1 here, I wrote block 2 here, like this. So I distributed all the 16 blocks. But what happens if you lose one node? You are going to lose the data, correct? So see here, in 4 data nodes are there. So I placed 4 blocks in each node. In that case, if any one machine goes down, then you are going to lose the data. When you lose the data, so
Yep.
remaining data in other blocks also unusable, right? So because you are not getting the complete data, I am going to lose, if one machine goes down, I am going to lose the first 6,000 rows. Then, right? Anyway, it doesn't work.
Yep.
right? If one node goes down, means that you are unable to use the data in the remaining machines too.
Yep.
So, right, and there is a most maximum probability to disk failure and system failure because we are using the inexpensive, low-priced machines.
Mm-hmm.
So, what we are doing here to come out from these things, right? Every block is replicated 3 times. Every block is replicated. Okay. So, what is the meaning of every block is replicated here?
This
Means
is a 2 copies.
yeah, right. So we are making the multiple copies of the data. So how we are making the multiple copies of the data? Then, sorry. Okay. So we have block one, block two, like block 16 blocks are created. Then,
Mm-hmm.
so when we install the Hadoop, so we'll get a file configuration file sdfs-site.xml, right? So in the same file, we have another property that is dfs dot replication. Okay, so
Okay.
dfs dot replication, so you can find this property in this file, so which is set to 3. So if it is set
So
to
means
2,
3 copy.
yeah, if it is set to 2, 2 copies. If it is set to
Okay.
3, 3 copies. Now every block is replicated 3 times. So like this you will get the block 1 3
Three
times.
times one node.
Yeah, block 1, right? So now like block 2 3 times. So like this. Okay, so each block is distributed multiple times. So now every block replicated 3 times. Now these blocks are equally distributed to all available data nodes. Okay, so that if any one data node goes down, then we can retrieve the other blocks. Okay,
Mm-hmm.
so we can retrieve the other blocks from a different node. We'll show you one small diagram here. Okay, see this one there. Okay, so we have one single file is a block 1 block 2 5 blocks are there,
Mm-hmm.
right? So we have the 5 nodes: data node 1, data node 2, node 3, node 4, node 5. So what we are doing now in the node 1, we are writing block 1 block 2 block 4. So this is all done internally, we are not going to do anything, Amit. So this background
Mm-hmm.
architecture, what I did, I wrote a copy command to the Amit directory. So these are the things which are going to run in the background. Okay, so we
Mm-hmm.
won't touch anything, so these are our default specified. So now these blocks are now like distributed to all the nodes. So if the data node 1 goes down while you are running the job, so data node 1 goes down, then see now you can retrieve the block 1 from the node
Node
2,
2.
and you can retrieve the block 2 from the node 4, and you can retrieve the block 4 from the node 2. So if any node goes down, we can retrieve the blocks from the other node. So at
Mm-hmm.
no point of time you are not going to lose the data,
Mm-hmm.
right? So there is no
So
chance. Almost your data is available all the time.
okay, so one question is here in this picture, like if data node 1, data node 2, data node 3 will go down, in that case, only 2 node will be available, data node 4 and 5. So in that case, we will lose the data from block 1, right?
No, 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 no. So yeah, here they follow one rule. So we have a replication placement policy. So the blocks are placed such a way that even if you lose continuously 2 nodes, 3 nodes are also down, we can able to retrieve that because we are writing this block 1 in another network, right? So general in that case, it will follow the some rules which is specified in a replication placement policy. So as you place these blocks as per the replication placement policy, what we are doing, this block is block 1, all the third replica is written into a different network environment. So if the entire is done, you can also get it from that way. So that way it will write the data.
So that means we need to maintain a a backup uh, a, a backup system also
No, no, no. We don't need backup, Amit, because so this is Hadoop. We are collecting the data from the production. So anyway,
Mhm,
every client will have your regular data processing. We are not touching that part.
mhm,
How to see? If you observe this architecture, Amit,
mhm,
if you are writing 1 TB file, right?
mhm,
Suppose you are having 1 TB file. When you are writing
mhm.
this 1 TB file into SDFS, replicate it 3 times becomes the 3 TB file. 1 TB
Yeah.
actual data becomes the 3 TB here. Again, if you take
Mhm.
a backup in some other location, your data becomes right. So you always has to pay a lot for the storage.
Yeah.
Remember. So this is only for the data. What we are doing now. Your client is having the data in the production database, or
Mhm,
your client is having the data in a server, or your client is having the data in some disks. So we are collecting the data from there and we are passing the data. That's it. So now we less prefer to back up the data.
mhm.
Okay, first thing. And second reason is even you no need to take the backup the data because the blocks are built such a way that we can able to retrieve because don't if the all this connected to one node, one net,
Mhm,
like one rack. So these are placed as a rack wise. So
mhm.
if this one rack is down, then you can also get it from the a different rack.
Okay.
Okay, so these are placed as a racks. So that is now the rack 1 will have the 3 and the rack 4 will have the 4 5. So now if the rack 1 goes down, that means entire 1 2 3 goes down. Then
Mhm.
you can get it from the 4 5. So like this it is going
Yeah.
to be configured. So
For 4, 5, we can get the data for block 2, 3, 5, and 4. But if we will see, the block 1 is not available in node 4 and node 5.
no, so here in this diagram we place a block like this, but in there, so every block is replicated into a different track. Okay, so that is now this 4 5 contains all the blocks of 1 to 5.
Okay.
Okay,
Okay.
in that case now don't consider this diagram. See, this is
Okay.
like all these blocks are placed to a replication placement policy. So
Mhm.
if you follow these policy rules, in the third rule they are specifying that place the blocks in a different track.
Okay.
Okay, so you have the three rules here, right? So see, this SDF's replication placement policy specifies one replication on no one node in a local rack. Okay. Second replication is in the next to data node in the same rack. Okay,
Mhm,
so that it's a
mhm.
proper network bandwidth to use the bandwidth because block 1 here, and if you write block 2 here in the node 5, then you should travel long, right? So it takes a high bandwidth. But if you place the block 2 in the next node or right immediately available, then you can get it. So that is that second point indicates the proper utilization of the bandwidth. First one is one replication in the same rack, and second replication another data node in the same rack, and third one is you can write in a different rack and a different node. Every block is placed like this. So now if this local rack or one rack goes down, we are getting the third replica from the different rack. For each blocks, third replica is available in a different rack.
So here rack is representing a node, right?
No, no, rack is its collection of the nodes.
Okay.
Will so you can see something like this Hadoop racks. So you know the book racks, right? So right, so this is the racks which are going to work, right? So like all these racks are placed in a data center. Okay, so now each will have the nodes,
Oh yeah.
right, like this. So all the racks are configured together as a cluster,
So rack, okay. So, mhm,
Yeah, that's okay, no problem. It's, you can say as of think that rack is a collection of nodes where each node contains some disks.
mhm,
Okay, but we don't need this architecture and kind of things. We don't know where it is, and we don't want anything. Actually, what I need, each node, I need an host IP address to connect the cluster, right? From a developer view, for us now, I don't need all the where these are placed and all those things. Okay,
mhm,
for me, what I need to host name to connect to this cluster. That's it.
mhm.
Okay, so now we least bother about this, right, how they configure and how they place the machines in this one, right? We don't consider that much.
Okay.
Okay, so like that is when you follow this replication placement policy, so you never going to lose the data. Okay, Amit, so clear this one?
Mhm, mhm. I think it was not copy.
Yeah, maybe. Right, so this is a replication placement policy. So like this, each blocks are distributed to all these nodes, so that if any one node goes down, we can retrieve the data from the other nodes. So clear enough? So how
Mhm,
the data is distributed to this bunch of disks?
mhm,
Okay, now, right, so like, so we have the block one, so like block two, so all the blocks are placed into the different data nodes.
mhm.
So now, so if your data node goes down, what happens? Nothing is going to be happen, right? So we can get the data from the we can get the blocks from the other data nodes, and the job is going to be processed. So it doesn't make any issue. It doesn't make any error, right? When you submit a job, right now,
Mhm.
it internally it will take care of the nodes and the blocks and availability. So it doesn't, we don't need to do anything to man, we don't need to do anything manually. If right, it will take care of internally. So no worries, it doesn't throw any error also. If any when machine goes down, then it will go to the another data node where the same blocks are available, and the job is going to be processed. Okay, so now you have to remember one point. Uh, okay, if the, right, if the data node goes down, so these machines are goes down, so we are not going to lose anything, right? It works perfect. If your name node goes down,
No, nothing will work.
yes, because you are unable to locate the index, you
Can
are
I?
unable to locate the files. So always we used to say one statement. So we call name node as a, is a
Last
SPOF,
one.
right? SPOF means name node is the reason, it's a single point of
Contact.
failure.
Okay.
Okay, if the Hadoop cluster is down, so what will be the reason for that? Name node. So name node is a single point of failure. So if the name node goes down, then because we are unable to locate the data into the data nodes, so think that the entire cluster is down.
Mhm.
Okay, so now, right, so to avoid this, what we are doing, we are taking one more node. Okay, so we are taking one more node, and we are calling it as a secondary name node.
Okay.
We call it as a secondary name node. Right, you know the checkpoint in SQL, right? So now, so what secondary name node contains? The snapshot
Of
image
the
of,
primary.
yeah, snapshot image of the name node. That means, so whatever the data you are having in the name node, we are writing this another copy in the secondary name node. Okay, so the snapshot image of the name node we are writing in the secondary name.
So whenever the name node will down, the secondary name node will work.
Yeah, we can no it. Yeah, we can get the data. We can get the snapshot from the secondary name node, and we can get the reference of the data in the data nodes.
Okay, so like whenever the name node will be down, automatically it will get connected to the secondary name node,
No,
right?
no. I'll tell you later. Let me give
Okay.
you more brief on this. Then I'll
Okay.
I'll come to your point, right? So now I'll give you more description about what is snapshot and how
Okay.
it writes. So this is the secondary name node. So what I'm saying here, the snapshot of the primary name node is written with the secondary name node. Okay, think that. Now, right. So here what I'm trying to do is trying to submit a job. Okay, so the client or the developer, the user, so he opened his shell or some hive terminal, or he wrote a program in Java, right? So to count the number of products. So when he submit the job, what is the meaning of submit the job? So he wrote select count star from the prod info, press enter. When you press the enter, means the job is submitted, correct? Right? So he
Yeah.
pressed the enter button. When he pressed the enter, the job is going to be submitted. When the client submits his job, so what we need, so from his laptop, office laptop, so he connected to the Hadoop cluster, and he opened the hive shell or SQL terminal, and he wrote a query, and he pressed the enter button. So when he submitted the job, then there is a one process called the job tracker. What it is, we call it as a job tracker. Okay, so generally job tracker resides into the name node. Okay, so the job tracker resides in a machine where you configure the name node. Then this job tracker will take the request from the client. Okay, so
So job tracker is another system or is the
another
same
process, it's a
where,
one process.
okay.
Okay,
So
all this
system will remain same.
yes,
System will remain same. Okay.
correct. Right. So job tracker is a one process. This process will take the request from the client. Now what it will do? Now it will go to the name node to locate where the data available. Right. So where this prod info is available. Right. So what are the blocks related to this file? So it will locate the reference in the name node. Then the job tracker comes to that particular data node. Okay. Now
Yeah.
every data node contains a one task tracker. Every data node in Hadoop cluster contains a task tracker. What it is? This is a task tracker. Now job tracker takes a request from the client, goes to the name node to locate the metadata about the file, and come to that particular data node and assign the job to the task tracker. Then what task tracker will do now? In every data node will have a task tracker. So in this machine, task tracker will take the blocks from this data node, and it perform the job, and it will submit the result to the job tracker. Job tracker submits it back to the client. Okay.
Okay.
So who will take the request here? Job tracker. Who runs the job? Task tracker. Right? In every data node will have a one task tracker. So remember this. Every data node contains a task trackers. So one important consideration, why Hadoop jobs are faster? Because the jobs are running where the data is available. You are not getting the data central location to process the data, right? The reason of placing the task tracker in each data node is, now this task tracker is taking the data in this data node.
Mm-hmm.
So it's because for this task tracker the data is local, correct? So where the data is available, in the same place you are running the job. So obviously your job is faster.
Yep.
Right. So now job tracker uh, gives it to the task tracker. Subtractor runs the job, give the output to the job tracker. Then job tracker will give output the name node.
So here in that case, like job tracker will submit the request to the each node and that will perform through the task tracker and task tracker return the output to the job tracker. So that is so obviously from all the node it will get the result and all result will go to the job trackers and then job tracker combine all the results sent back to the
Client submits it to the
client,
client.
right?
Correct. Because
Okay.
I have to count the data in all the blocks, not the blocks in one data node.
Mm-hmm.
Right. So because wherever the blocks are available for the similar file, So the jobs are running into those machines.
Okay, so there may be possible chances, suppose obviously job tracker
Down.
send the to task tracker now. So for one node, there might be chances is let's say example B1 block task tracker is completed and it sent the result to the job tracker. For B1, B2 and for B1 and B2, like first to three data node,
Yes.
all the task tracker return their output, but
Correct.
there might be the chances for the node 3 for B3 block node still is running. So in that moment, will job tracker will submit the whatever the output he already
No,
got
no, no.
from first three? No. So once it will get all the result, then it will final send the result to client.
Yes. So because
Okay.
what we do, we insert multiple processes at the same time, right?
Mhm.
So four processes are running at the same time in the four nodes, right?
Mhm.
Once all are completed, then only it will be given to you. Because
Okay.
the complete count completes when you come to the blocks in the last block. When you count the rows in the last block, then only the job is completed, right?
Okay.
So you can
And they
ask me
say
one
all
more
these are
question.
the parallel processing. Okay.
It's not
All
a
these are
parallel.
the
No,
parallel process.
no parallel processing. Parallel. It's a one job. Not you're running multiple jobs. Remember, parallel
Mm-hmm.
processing is running multiple jobs at the same time. Here it's only one job. Did you observe, Amit?
Yeah, one job.
No, you are saying parallel processing. Parallel processing means running the multiple jobs. Job 1, job 2, job 3, job 4 at the same time. But
No,
here, how
no.
many jobs you're running? Only one
Um,
job.
No, yeah, one job
Is
the user
running.
submit.
Yeah, one job is running parallelly. That's it.
Yeah, one job running parallelly
In
on
all the
each
node.
four node.
Correct.
Okay.
Yes, yeah, correct. So right now, suppose this is so what we call generally. So the Hadoop. Okay, where we are submission.
Or application data content is deleted, I think.
See, it's there. It's in a white color.
Oh, is a color changer.
Yeah, no problem. Okay, so right. So coming to what we call it as a Hadoop daemons or Hadoop processes. Okay, generally we call it as Hadoop daemons or the Hadoop processes. So always Hadoop is configured as a master and slave architecture, right? So consider as a master and slave architecture. A second, something happened here. Let me delete all these things. Yeah. So Hadoop daemons are the Hadoop process which is running in the cluster. So always Hadoop is configured as a master and slave architecture, right? So Hadoop is configured as a master and slave architecture. And when we talk about Hadoop, we always talk about Hadoop in the two ways. That is a Hadoop before 2.0 version and Hadoop 2.0 onwards. Okay, so we always talk in like before 2.0 and after 2.0, right? So now what is in a Hadoop before 2.0 and what the difference comes Hadoop after 2.0, we'll see now, right? So Hadoop before 2.0, see if you see this diagram, so what are the master nodes? Name node,
Name node is the
job,
master node,
yeah,
yeah.
name node, job tracker and secondary name node. So these are all the masters, that is name node, then the secondary name node, and job tracker are the master nodes, right? So what are the slaves now?
The data nodes.
Yeah, data nodes and the task tracker,
Task tracker, yeah.
right? So these are the slave nodes, right? So now Hadoop 2.0 onwards. Now I have one question here. Okay, so now what we are doing, we are writing the job tracker. We are having the data in the data nodes. The job tracker is taking the request from the client. Task tracker is running the job. So what happens here? As long as the job tracker submit the job to the task tracker, then the task tracker will run the job. Correct? So as long as the task tracker is running the job tracker will monitor the job. It won't do anything. So it will wait for the output from the task tracker.
Yeah.
Okay, that is, now the job tracker will take the request from the client, locates the data from the NAM node, and assign the job to the task tracker, and it will wait for the output. That means it won't take the second request from the client now until the job one finished.
Oh.
Okay, so until one task is completed, it submits the output, then only it can take the second request from the client. Right? It should complete one job. That is, in this case, there is no parallel processing because I cannot able to
Yeah.
run multiple jobs at the same time. Because job tracker submits the task to the task tracker and it is monitoring. It is already busy with the monitoring, so it cannot take second request from the client. So what is the issue here? There is no parallel processing.
Yeah, means until unless one job will not complete, will not take the another request. So
Yeah,
we need
another
to
job.
wait and
Correct. Yeah, you know the giants, MySQL giants,
yeah.
right? We write inner giant, or we wrote a complex select statement, right? So nested select statement that indicates two jobs. Now it's a difficult to write here, correct? So no parallel processing. So we cannot run. It cannot process multiple jobs at the same time, right? When we use a job tracker and task tracker, it's a fixed, correct? Right.
Yep.
Now second thing, we come to the secondary name node. What we are doing in the secondary name node, we are writing the name node snapshot in
Yes.
the secondary name node. So we write something like this. Whenever the checkpoint occurs, what is a checkpoint? Like some backup time. Like it's scheduled to run every 1 hour. So at 10:30, okay. So I took the backup of the name node 1 to the name node 2. That is at the 10:30. So now I have updated name node backup into the secondary name node. Okay. Name node 2 is available. So next backup time is 11:30 considered. Now, but what happens? The primary name node is down at 11:15. Then
Okay.
can you retrieve the data between 10:30 to 11:15?
Uh, we can retrieve, yeah.
No, we cannot retrieve. You can retrieve up to
So
10:30 because the backup was done at the 10:30 to the name node 2. So next backup time is 11:30. So now whatever you write between 10:30 to 11:15, where do you find if it goes down?
oh yeah, got it.
Got it? That
Yeah.
means, right, at some point of time you are going to lose the data. You need to
Yeah.
down the Hadoop cluster and you need to lose the data, right?
Yeah. From 10:30 to 11:15 that
Yeah,
will lose.
right.
Yeah.
You're going to lose some data. That is, and it gives the no high availability. You cannot make 24 by
Yeah.
7 up and run with this reason. Okay, so these are the two drawbacks in Hadoop before 2.0.
Okay.
Okay, so in a before 2.0 we are unable to run the parallel processing and we are unable to perform the we are unable to give the 24 by 7 up and run, no high availability,
11% no high
right?
availability.
So now we have to overcome these issues. So what we did from 2.0 onwards in the newest version of the Hadoop, right? So instead of the job tracker, we started a new process. So this is what we call map reduce. Now what we did, we used a yarn. We are using a yarn. So what yarn stands for? Yet another resource negotiator. Okay, what yarn stands for? Yet another resource negotiator. Yeah. So what we are doing here, instead of the job tracker, we are using a resource manager. You can see the name, resource, right? Instead of the job tracker, we are using a resource manager, and instead of the task tracker, we are using a node manager.
Okay.
Okay, so we are using a node manager now. So instead of the job tracker, that is, we will have a resource manager here. Okay, and we'll have a node manager here in every data node.
Okay.
Okay, now see what happens here. Whenever the job is submitted, resource manager will take a request from the client, and
Okay.
it will create the resources to run the job. And resource manager will have something assistant called like application manager, application master.
Okay.
Okay, application master. Now resource manager will take the request from the client, create the resources, and it tells the node manager to run the job, and it tells the application master to monitor the job. See, previously 2 employees, but here what we did, we recruited 3 employees. Okay, 3 people are working. So first I'll take the job from the client, and I'll tell the node manager to run the job, and I'll tell the application master to monitor the job. So application master is busy in monitoring the job, node manager is busy in running the job, so I can take one more request from the client.
Okay.
Clear now? So
Yep.
now the resource manager and application master will together as a resource manager, right? We don't have separate application. It's like something assistant you can consider, right? So the resource manager and application master together we call it as a resource manager. So as you can see, this resource manager will create the resources to run the job. Okay, and so application master is to monitor the job. It will monitor the job. Then who runs the job? Node manager
Node
will
manager.
run the job. So this is the new Hadoop environment. So every job which we are going to run is run with the yarn, so that we can able to run parallel processing. We can able to run multiple jobs at the same time.
Okay.
So how many jobs, how much resource you can able to allocate, that many number of jobs you can run. Right, see here.
Also, okay, so like for first, the user is already submit one job, is still running.
Yes,
Now another user can submit the another
another
job.
job,
So
correct.
the second job will go to the resource manager. It will allocate the resources, and then from there it forward to the node manager. So node manager, so in that case, is working like a thread kind of system.
Yes, that is the reason, correct. It will create a resource containers, memory containers. Each
Okay.
job will assign a job some memory. So job one will allocate some memory. Job two for it will allocate some memory. It will create a resources. That's the reason we use the word resource will create a resource to run the job. So that each job is its own resources now. Okay,
Oh.
right. See, this is in my Windows machine. So how many applications I can open at the same time? 3, 4, 5, 10.
Yeah.
But at some point of time, my system will goes down, right?
Yeah.
Till I open multiple applications, it may get stuck up. That means there is no
Yeah.
resource available. Correct?
Yeah.
So the
Yeah.
same way, so how many resources you can able to provide, that many number of jobs you can able to run. Right?
Yeah.
So based upon the number of resources are available. So once you don't have any resources, you can attend a job. It's a basic thing. Right? So internally, resource will create some memory containers that I'll teach you in another chapter. We have a specific chapter on that. So there I'll dig deep into what happens in the background. Right? As of now, it will create a memory container. So each job runs onto that specific memory area. So like that. Okay.
Okay.
So now parallel processing is completed. So we can run multiple jobs.
So
Now,
for this one also we need to install the yarn, right?
yeah, but right now the Hadoop by default comes with a yarn. So you no need to do
Okay.
anything. It's a default
Okay.
Hadoop comes with a yarn. So no 2.0, it comes with a it's a before 2.0 like 1.4, 1.3, it comes with a map reduce like job tracker and task tracker.
Okay.
Okay, so now this parallel processing is resolved. Next issue is no high availability. Now what we do here, so in 2.0 we are taking one more name node. Okay, I'm taking one more name node, and what I am doing here in the name node, I am writing the two writes. So generally, so different people will call with a different name. So most of the time we call it as HCA node, high availability node. What we call? We call it as a HCA node, high availability node. Different people will, some people will call it as resource node or shared node, journal node, quorum node. It's a different thing, but preferably we all use the term word here, HCA node, high availability node. So what I'll do here, I'll write it twice, two writes, means whatever I write here, I also write into this machine. Okay, so if you write something here, in the same time we also write here.
Okay.
And the Hadoop admin, what he do, he enable the auto fencing. So there is a one concept in the admin session people, so we call it as a auto fencing. Okay, so what this auto fencing do now, if one is down, automatically second will up and run, zero downtime. Okay, so if you enable HA for the Hadoop cluster with a concept called auto fencing, if the primary name node goes down, if this goes down, it will up and run.
Okay.
Right, if it is down, it will up and run. So one is a primary and then other one is a high availability node. One is
So if
active,
in the
only
case,
one is active.
okay. So, okay. So there may be the name node is like down, then high availability node will be available. So there might be the chances if both is down then.
You have to take the backup of the name node data. That's it. In that case, if you think that you may lose the data, because how much data becomes this very small, right? You are only writing one path. So even
Hmm.
if you take 100 CP 100 TB node, but this file doesn't make gross more than a TB, more than a gigabytes of the data, right?
Okay.
So if you write some 10 lakh files,
Hmm.
but what you're writing in the name node, you're writing only the reference, right? One line
Yeah.
about each and
Yeah.
every file. So now
Yeah.
yeah,
I'm just like
yes,
just suddenly came. Yeah.
yeah,
So.
that's a good point, right? Because that is everyone will get an issue. We can in 2.0 we can also take the backup of this image file. So where
Hmm.
node writing this image data, we call this file as a fs image file, right? So this is admin will have an access for this. We have a fs image file. Okay, so
Hmm.
that is name node writes all this metadata into a file with the name fs image file. So we have a one command is available, oiv. Okay, oiv is a
Hmm.
utility, linux utility, offline image viewer. So I can take the backup of this ms image file into my local file system, then I can upload into a disk somewhere, or you can copy into pen drive, so you have the backup.
Okay. So also here like high availability node and name node, and there is another is a secondary node, name node, that is a snapshot of name node.
Right.
So if so that means is there any possibility like if name node and HA node get down, then we'll get the from the snapshot means
uh,
the secondary name node.
but actually from 2.0 we don't give much priority secondary name node.
Okay, so that was is still so before 2.0
Yes,
secondary node.
correct.
Okay.
If you want to configure, you can use that one. So
Mhm.
that is even some point of the time you lose the data if you have the secondary name node because of this
Okay.
checkpoint issue. Right. So generally we don't use this in secondary name node, but I cannot say it's not possible. You can also use all these three things together. And remember one point, we can configure multiple HA nodes. In Hadoop 2.0, it's simply one rule. If you in your interview, if somebody will ask you the question, how many name nodes Hadoop cluster contains? if this question. So what will your answer? First you have to ask them. So you are talking about before 2.0 or after 2.0. So if it is a before 2.0, there is only one name node and one secondary name node. But after 2.0 onwards, we can configure multiple name nodes. So each one
Okay.
active and remaining are the standby. So you can take 3 HA nodes, you can configure 4 HA nodes. This is up to you now. So you can have the multiple name nodes
Okay.
and the multiple data nodes from the 2.0 onwards.
Okay. And but the high availability node will be one.
No.
For
It
more
can be,
for
no. You have to say active node is one.
okay.
Only one is active.
Yeah, one is active. If in the case of name node is get down, then it will get from the high availability node.
Right. Yeah. HA node is a name node. Right. Because it's same whatever you're writing here, I'm also writing here. So it's also a name node, and we call it as a HA node, high availability node. Right. To make it automatically up and run if you lose this one. That's the reason. That's the reason
Yeah.
we call it HA node as shared node.
Okay. So if we have a multiple name node, means after 2.2, after 2.0, if we have a like we configure multiple name node, like 3 name node, but we and for high availability node will be one, right?
No. See, you configure three name nodes are the HA nodes. Here I am calling it as a word HA node, but it's also name node.
Yeah. Uh, uh, uh,
I mean,
so
you can see now you can configure multiple nodes like this. It's this also HA node, this is also HA node, right? That means three writes. Whatever I write here, I also write here. I also write here. I also write here. One is connected. One is connected active, and other one is a standby. Remaining things are connected. Maybe you can enable auto fencing or not.
okay, got it.
Right. So now, so Hadoop 2.0 onwards. What are the master nodes
We
now?
we can configure multiple name nodes
So what are the master nodes? Name node. So
and
name node,
high
then HA node,
high availability.
right?
Yeah.
So name node, HA node, then resource manager. If you configure secondary name node, is also known as a master node, right? So what are the slave nodes here, right? The data nodes and the node managers.
Yeah, not
Okay, so these are the slave nodes. And remember, in Hadoop 2.0, we have an option to use both the things. I can also use a map reduce, or I can also use a yarn, right? That means
oh
I can run some jobs with a map reduce, I can run some jobs with a yarn. Okay, so
oh
I want to job tracker to run the job, you can also do that. And I want to run the job with the yarn, you can also do that thing. So that is, we can run both the job, both we can use both the things, right, from 2.0. But before 2.0 you cannot use yarn.
yeah, before 2.0. Yeah.
Right. So Hadoop to it's your wish now. So you can, if you want to
Okay.
use a map reduce, yes, you can use a job tracker as a master and a task tracker as a slave, and you can run job with a job tracker. And also you can run a job with a yarn. Both are available from 2.0 onwards.
So, okay, so that means like if I will consider example like we are working in this Hadoop section, like the version from 1.5. So in that time we have that only 1.5, that means a map reducer.
Only map
Every
reduce, no
system
yarn.
is configured now. Yeah, so and the later on now new version introduced, we want the new version also. So we on the existing system, we can also install the yarn and can utilize as a old one and the new one both, right?
Yeah. That means you have to use, you're saying that upgrading. You're upgrading
Yeah,
cluster node.
upgrading, yeah, and
You're up,
also supporting the old one.
yes. So when you're upgrading to the newest version, so you have both the things available, map reduce and
Okay.
yarn. So generally we have a property. So this you'll get the interview. What is the property? So map read dot framework dot name is the one property. So if it is this property set to classic, then the job runs with a map reduce. Okay, or if you specify this property to the yarn, so if you write here yarn, the job runs with a yarn. That is a background. So which one
So,
to run the
and
job?
what is the file name where we need to configure this thing?
So you can this submit the job as a job parameter. We can submit this as a job parameter. Okay, so two things. The default one is we can configure in sdf7set.xml. Okay, so that is the
What is the file name where we will need to pass these two?
uh, no, we have the two options. I want to make one thing default for every jobs.
Okay.
When you want to make default for every jobs, then you have to make this as property. You have to make this property enable in sdf-site.xml.
Okay.
Then every job runs with the whatever is specified. Suppose I'm running a one job one. I'm writing one program one in Java. So now I want to run this job with a map radius where remaining jobs are in yarn. Then you have to pass this property as a parameter to this job submission.
Okay.
Okay, so one is the default to the cluster and other one is a specific to the job.
Okay.
Now you're clear,
Yeah.
right? So now you can use both the Hadoop 2.0. It's everything is available, right? So this is now you understood, right? So let me
Yeah.
add a little bit more. So now if the Hadoop cluster is running, that means in the Hadoop cluster both we right. So this is architecture point of view. But when you are working on as a developer job role, we represent like this. We represent SDFS, then we represent MapReduce, then yarn. So if somebody tell you, your manager says, Amit, go and start SDFS or go and stop SDFS. That means what you have to do? Name node, say rain data nodes. So these are all comes to the SDFS file system where information about the files are available, right? Name node, data node, secondary node. So these all represent the SDFS. Okay. Suppose if it says stop the map reduce or run job with the map reduce, that means job tracker and task tracker represent the map reduce.
Mm-hmm.
What is the yarn demands? Or submit the job with the yarn or start yarn. That means you
Resource
should have the
manager,
resource manager and
resource manager,
node
and
manager.
node manager.
Right. So when we are working, we use these three words, right? Start SDFS or stop SDFS, or you are having an issue with SDFS. So when you are having this issue with SDFS means issue with these three, not this map rotation yard, right? So this is so if a cluster is running successfully, that means the cluster is running with SDFS and map radius. Okay. So one more question. You started SDFS, but we have not started the map rotation yard. Can we able to run the job?
Yeah, we.
See, I have started SDFS, but I have not started the map reduction yard. Can we able to run the
So,
job?
no,
No, right? Because
because we need the JT and TT means job tracker and the task tracker.
yes, our resource manager you need to take the
Yeah,
request from the
yeah,
client. That
yeah,
is correct. Super. So if you have only SDFS, I can able to copy the data,
yeah,
right? I can able to copy the files to the Hadoop cluster. But to run a job, for the second
yeah,
job in this diagram, right?
yeah,
Count the number of this
yeah,
is job,
yeah,
right? So for this copying, you need only SDFS, but to run the job,
yeah.
either name node
We
or
need the.
the resource manager has to take the request. So
Yeah.
right, that means the users always able to run the job if the map represent or yard is started and up and running.
Mm-hmm.
Okay, so now so generally how we use here, some clients will use SDFS, right? So now we come to the first point, right, where we yeah, so right, right. So now first point, so where we store the data in SDFS, then how we are running the day, how we are passing the job, if I can use a map reduce, right? So it's a distributing the data to SDFS and processing the data to the map reduce, correct? So then, so you are writing the data in the data nodes and maintain a reference in the name node and submitting the job and processing the job can be done by the job tracker and job is executed by the task tracker. This is you can use in the newest version. So this is generally before
before 2.0.
2.0. Now in the newest versions, SDFS, I'm storing the
Yes.
data and we are running
Yeah.
yarn, right? So Hadoop 2.0 onwards. Okay, so SDFS plus yarn. So we have the different engines are available. Some people also use Tej. Okay, Tej is also an execution engine. General are available Hadoop 2.0 onwards, and it will be used by Hortonworks. It's another business in the Hadoop. Okay, these are the execution engines. Now see here, what is the Hadoop now? We are distributing the data to SDFS and we are passing the data to the MapReduce or yarn or a Tej. So now see here, I can write a program in a Java. So no change here. My program is in Java. My data is available in SDFS and I'm using the execution engine is a MapReduce. Okay, that is client wrote a program in Java and submitted a job. Then the MapReduce is processed the job. Or client or user wrote a job in Hive or SQL or anywhere, then the job takes data from the SDFS and executes under the yarn execution environment. Now see here, this the coding is doesn't change. Okay, so the execution engines are the different.
No.
So now you got clear idea. Any confusion?
No.
Right. So do you think hard teacher is different thing or easy?
Yeah, like few new concepts.
Yeah, generally
For
it's
the first idea, first time we will think, but after
yes,
getting all these things, it will remain it's easy.
yes, correct. So no, just I'll make this architecture. It's a very simple. But if you go through a textbook to read this architecture, it's very difficult one.
Oh.
So it's so much complexity in their words. Right. So I have added diagram here. So I also use this difference. If you have this diagram along with you, that's it.
Yeah.
Right. It you can use this one. Okay. So do you have any question or any confusion?
No.
Right. So now what you have to do here? Once whenever you have the time, right? So if you have a time, just you can define the definitions here. So what is a name node? What is a data nodes? Right? So what is a map reduce
Resource
dimensions?
manager.
Right? So what are the map reduce dimensions? What are the yarn dimensions? Right? So how many name nodes we can have? Same thing, how many data nodes we can have? Right? What is a HA node? Right? What is the replication placement policy? Right? Have the job processed in Hadoop cluster. The difference between Hadoop before 2.0
And after.
and after, and what are the execution engines to use in Hadoop. Right? I think now you know all these things.
Yeah.
Right. So this is Hadoop dimensions and the Hadoop processes. There it is. So did I forget anything here? Right. So yeah, you should. What is a local file system and SDF file system?
Mhm.
Right. So and don't get confused what a local file system and SDF file system. So everybody will have a lot of confusion to identify the differences, right? LFS and
Mhm.
SDFS. So where do you find Hadoop configuration files?
In the local file system,
Right. So I told SDFS and site.xml. Where do you find this file?
which one?
Right. This configuration file SDFS and site.xml. So where do you locate this file in your system?
That should be in the local file system.
Right. So it's a directory where you install the Hadoop. Hadoop home.
Yeah, yeah,
Yeah. In the Hadoop
yeah,
home conf directory.
yeah,
Okay. So that's a local file system, not
mhm,
SDFS.
yeah, yeah.
Right. So
SDSF, we only just copy the data file.
correct. Right. So now I'm going to teach you how to connect to Hadoop cluster. Meanwhile, let me start this. So now it's a very first day in your office. Okay. So what do you need to connect to the Hadoop cluster and how to connect to the Hadoop cluster? Okay. Right. And we also learn what is a web UI. Right. Now, first thing is you're a new developer. So what is the first thing? Yet your admin has to create a the privileges to connect to the
Access.
Hadoop cluster. You
Yeah.
should get your username and the password, right? So very first thing is we should know the host name of the name node, right? So now remember, Amit, always connection to the Hadoop cluster takes place to the name node only. Okay,
Mhm.
right? I think just let me save this. Okay, so now this is the name node. And these are all the data nodes. So now we are going to learn it's very important topic, Amit. So which we work.
Mhm.
So now I just generally this is the answer for how to see how to connect the Hadoop cluster, how to see how many data nodes are there configured Hadoop cluster, how many are running, how many are failed. So that all those things you are going to learn now. So how to check what are the jobs are running in Hadoop cluster and whatever we discussed today right now what is the name node. So you are going to see all those things now. Okay.
Okay.
So right now this is the data nodes, right? So as I told, every data node contains two file
Yeah,
systems,
two things.
right? It's a local file system, and other one is a
And the is
HDFS
SDFS.
file system. It's a name node, and all these are connected to the
Okay.
master node, right? So now, right. So this is the Hadoop cluster. So now I'm a new developer. In right now it's the first day. I'm in office now, right? So I have to connect with the Hadoop cluster. So what you have to remember, first rule you have to remember is always connection, okay? Connection to the name node, connection to the cluster takes place through name node only,
Okay.
okay? That means if you want to connect to the Hadoop cluster, so where you have to connect? You have to connect to the name
Master
node.
machine.
Yeah, you have to connect to the name node. So that is once you connect to the Hadoop cluster means you are connected to the entire all the data nodes.
Oh,
Okay, so this one point. Second one, now I told you that a single file as a blocks distributed to all the data nodes. That means one single file, some blocks are available here, few blocks are available, right? So
Mm-hmm.
when it is coming to the SDFS, we never differentiate the data node 1 SDFS, data node 2 SDFS, data node 3 SDFS. It is a one SDFS. Okay, we always consider this as a one SDFS, right? So don't differentiate the data node 1 SDFS, data node 2 SDFS, data node 3 SDFS. It's a one SDFS. Okay, right. So that is we never we means here both dev and admin, we
Yeah.
never able to. So suppose what I did, I am trying to connect to this node 1, this node 1, and I'm trying to access this SDFS. Is it possible?
Mm-hmm.
No, right? I'll repeat here, Amit. So I'm a sysadmin and also working as a Hadoop admin. So what I did,
Mm-hmm.
I have connected to this data node. Then
Mm-hmm.
I have an access to this local file system. That's the default thing. Now,
Mm-hmm.
then SDFS file system contains some block 1, block 2, block 3. So I want to access that one. Is it possible? No, right? We never able to connect to data node, connect to SDFS through data nodes, right? We never able to connect to SDFS through the data nodes. Okay, that means if you
Mm-hmm.
are trying to connect this this data node and to access the SDFS, not possible. That means either a developer or admin cannot able to connect to the SDFS to access the data,
Okay.
because even if you connect, but what do, you'll get only the some blocks, some part of the
Yeah.
data, right?
Yeah.
And I'm not differentiating this was a data node one is one part of the SDFS in entire Hadoop cluster.
Mm-hmm.
That is the reason. So no user will connect the SDFS file system through the data nodes. I can able to connect to this data node 1 local file system, right?
Mm-hmm.
So we can connect to data nodes to access local file system, but we never access, not
The,
actually never, actually not possible to
to SDFS.
access STFS, right? Suppose your project manager assign a job, Amit, go and install the Spark in node 3. What is the job here? So you have to install Spark in node 3. Okay, this is job given by your manager to you. So now this is
Okay.
the node 3. Now you have to connect to this machine. Now where the installation takes place? In a local file system,
Local file system. Yeah.
right? So now
So in that cases, we can connect to the local file system, right?
right now first thing is connect to, so connect to node 3.
The node 3.
That is, you can use SSH, then IP address of the node
Mm-hmm.
3.
Mm-hmm.
Then you are connected. It will ask the username and password.
Then yeah, then only we are only to connect to node 3 with the local file system.
Yeah, to access the local file system. So
And
now you connected
yeah.
to this local file system. Then you can install the Spark.
Okay.
Okay. So that is to connect to the Hadoop cluster through access place. Always connection takes place to the name node.
Name node.
And no users, either developer or admin, can access the SDFS through the data nodes. To access the SDFS means you have to access through the name node only. That is connecting to the SDFS or accessing the data in SDFS can be done through the name node. And apart
Mm-hmm.
from that, you can understand because the reference written here, right? So the file
Mm-hmm.
information is written into the name node. So to access any file,
Yeah.
so you have to get the reference from metadata from the name node. That is the one
Yeah.
best reason, right? So to connect to the other person, you need to.
Yeah.
So that is the reason we always connect the cluster to the name node.
Yeah.
Okay. So now what we need the host name of the name node.
Name node.
So generally we know that, right? So most of the time host name is related to the client business name, right? So if you are working for a Bank of America, then you write bank1 dot cluster1 dot com. So this is going to be the host name, something like, right? So it like in this form, right? Host name, right? And second thing, what we need to have, we should have the privileges to connect to, right? So if you know the host name, but you should have the privileges, right? You should request the admin to grant the privileges to connect the Hadoop cluster. So you should have the privileges to connect to the cluster. So now in your office laptop, what we need a remote clients like Putty, and we need a Chrome browser. We need any browser to connect to. Okay, so we need these three things to connect to the Hadoop cluster, right? So
Mhm.
now in your office laptop, what are the softwares you need to have? Only Putty and browser you need to have. That's it. And this is will be you'll get a mail through your admin team. So in a very first day or second day, you'll get the project documentation. There you can see all these host names and everything. Okay, so let me show you here. Uh, Take a note. So what is the IP address? How to check the host name? So you know bit Linux, Amit?
Yeah, little bit.
Yeah, we don't need the too much line. We need only 10 to 12 comments. So at any point
Yeah,
of time,
ls minus,
right?
yeah.
Correct. So because one thing here, we never open our mail to see the host name. It's a difficult, right? And it's remembering is also difficult,
Yeah,
right? And I cannot open my first day mail every day. So
yeah.
what we do, we have a one command. So in the Linux, if you write cat slash etc slash hosts, will give the host names which are configured for the Hadoop cluster. So remember this command. What is the command? Cat slash
FATC
etc slash
source.
host will give the host name, right? And you can also run the command like host name
So
slash
first we need to connect through the putty, right?
no, I'm not connecting. Just even I need to know the host name, right? So I use this one, right? And to
Okay.
see the IP address, we use the command in Windows IP config, in the Linux if config to see the IP address, right? So we need host name or the IP address, right? Okay, you forget about this environment. So what we need first, we need a host name, or if no, the IP address also works. Okay, right? So at any point of time to retrieve the host name, you can run this command to see the IP address. Run this if config command. Okay,
Mhm.
so now, so I have to connect to the Hadoop cluster. So what I need to do? First, open the putty. Okay, so write the host name here. Okay, so open the host name and open. Right, so it will ask the username to connect to the Hadoop cluster. So enter the username sent by your admin team. So it will ask the password. That is, now I have connected the Hadoop cluster. To check the version, run the command Hadoop space version. This is the Hadoop version. Okay, so now I have connected the Hadoop cluster to the putty. Right. So now from here, you can submit a job. You can go to any directory and you can run the job. See, let me show you some files here. So if you Hadoop for me cd usr lib,
Mhm.
then Hadoop. So this is the Hadoop home. Okay, this is the Hadoop home where Hadoop is installed in this directory. Right? Even if you want to install anything, you can also install here. Come to this directory, and you know the how to install in Linux the same way how to install like a tarball kind of thing. Okay,
Okay.
so it's untar
Mhm.
kind, right? That's now everything we install in this directory, right? So we have SDFS, MapReduce, Yarn, at H catalog, Impala, right? SQLR, Spark, Cube. So these all the things are available. So this generally in a cloud era we use user LIB path. Okay, so now this is I have connected to the Hadoop cluster to the name node. So if you want to run a submit job or anything, you can do from here. Okay, so second thing, we have a concept called web UI. We have web UI. That is, I can check all the Hadoop dimensions through the browser. Web user interface. Okay, web user interface, web UI. And you have to remember this number is very mandatory. If you don't know this number, means you don't work with Hadoop. Some people will come with experience of 3 years, but if I ask you what is the name node web UI, if you don't tell this number, it's a fake, because it's like alphabets in Hadoop. It's a very basic thing, and every developer should remember these numbers. Okay, it's mandatory. 50070 for the name node and 50075 for the data nodes. Okay, Amit, remember these numbers. Okay,
Yep.
then 50030 for the job trackers and 50060 for the task
So
trackers.
these are the generic number that is assigned to name node, data node, and job tracker,
No,
task
no,
tracker.
no, no, no. We'll tell you. Okay, let me write these numbers. 50090 for the secondary name node. These are the web user ports. Means to connect to the name node through the browser, I use this number.
Okay, so
Okay,
these are the so port number, right?
web ports, not the system ports
Okay.
which we configure. Right?
Okay.
It's a web UI browser ports.
Okay.
Okay, we'll show you. 50090 for the secondary name node and 8088 for the yarn. And suppose if you want to GUI, graphical user interface for the Hadoop, it's a 8888. It's for the Hue web UI, right? So these are the web UI numbers, right? Now I'm going to show you one thing: how to check the
Through the browser.
information about name node. It's a your interview question. What you want to know that you want to see the information. So it's day one, right? We are talking about. So now I want to check the information about the Hadoop name node. So open a browser. Okay, you can use a Google Chrome. Then what you have to do, you have to write the host name. You have to write the host name or IP address colon 50070. You have to run this command. So now I write the IP address here. Oh, not this one. So what is the IP address? Yeah, write the IP address here. Then write 50070. Okay, so this is the information about the name node. Okay, so this is the host name and this is the port which is name node is available, system port 8020, and the status of the name node is active. So when the name node is started, what is the ID of the cluster, right? So now we can see all the information about the name node from this place, right? So this is how to check the information about the name node.
Mhm.
Okay, so how to check the number of data nodes? How to check the data nodes? Right. So if you open this, the name node web UI, if you see here utilities, correct? Click the browse the file system. Okay, what you have to do? You have to click the browse the file
Browse
system
file system.
to access the SDFS. Okay, so right, let it be. What is the data node web UI? 50075.
501, yes, sir.
Right, see here.
75.
Right,
Yeah.
I'm trying to access the SDFS from the data node. What I'm doing now, I'm trying to access the SDFS to the the data node. So as usual, you have to copy the host name, right? Host name
And just change that number to, yeah,
50075
75.
colon 50075. Press enter. Can you connect any files here? Can you able see the files? No, right?
Uh,
Because what I told in the diagram, no user can connect to the data nodes directly, right? So the
Okay.
reason I
Okay.
cannot able to access anything. How to access the HDFS? You have to connect to the name node. So connect to the name node, go to the utilities, click the browse the file system. Now you can access the HDFS. See, this is the files which are available in Hadoop HDFS. Okay, clear?
Mhm.
Right. So this is how to access the HDFS. Right? How to access the HDFS. That is, you have to navigate to the name node API and select the option file browser. Okay. So then you'll get the browse the file system. Then you'll get the access to the HDFS file system. Okay. So how to check the number of data nodes? Check the data nodes. Same thing. If you open the name node API, if you scroll down, you can see the live nodes. Can you see here? Live nodes.
Yeah. Yeah.
Right? If you click on the live nodes, you can see the each data node and the host name of that particular data node.
Mhm.
Okay. So what you have to do, you have to click on the live nodes. You have to click on the name node API. Scroll down. You have to click on the live nodes. So when you click on the live nodes, now you can see the host name of each data node and the information about that data node host name. Okay. Right? So suppose if
Mhm.
you want to connect to any specific data node, then use the command ssh space, write the host name, press enter. So it will ask the password to connect to that machine. Connect it. Right. Now you can do in that machine. So you connect it to that particular data node. So now you want to submit a job. Yes, you can submit a job. Navigate to city Spark. So where it is under user, everything is available under user reliability. Remember this path, okay? If you take the Spark, then in the bin directory, ls. So now I can use this Spark submit to submit the Spark job. That's it.
Mhm.
Okay. So that is I connected a different machine through SSH, and then I navigate to this directory and I use this command Spark submit to submit the Spark job from the node 3.
Yep.
Right. So this is how to connect the name node and how to connect to the data nodes. Right. So next one, job tracker. Right. What is the job tracker API? 50030. Right. So
Mm.
colon 50030. It won't display anything because there is no job tracker is running in my cluster. The same thing.
Mhm.
What is the secondary name node? Sorry, task tracker 50060. It's
So
not
that
running.
will also, we will be not, like a job tracker is not running, then definitely that will also not running.
Right. Correct. So now 50090 for the secondary name node.
That we should get it.
Right. So it's the secondary name node. Right. So see checkpoint time. So checkpoint period. So every during this checkpoint, the snapshot is taken back up to the secondary name node. It's the secondary name node. Now I'm using yarn to submit the jobs. So now this is what we do in every day. Right. So what you're going to learn now is how to see the jobs running in Hadoop cluster. So now your team, different people will submit the jobs, right? So everybody.
Mm-hmm.
So now I just want to see what are the jobs running in Hadoop cluster. You
Mm-hmm.
also submitted a one job. Now you want to see the status of that particular job.
Mm-hmm.
Okay. So how to see the jobs running in a Hadoop cluster? So as I told that Hadoop 2.0, we are using Yarn as an
Yeah.
execution engine to submit the
Yeah.
jobs. So now, right, as well host name, then here 8088, right? It's a Yarn page, right? So now all the jobs are running are displayed here. Okay, so let me show one thing.
So here is like it's all is 000. So
Where, yeah, no jobs are running now.
yeah. Mm-hmm.
See, so I'm going to show you some jobs here. I've started a Hive. Okay, so
Mm-hmm.
it's a SQL program. So show tables will list the tables, right? So now you can see that these are the tables. Okay, so let me write some job. Suppose if I
Mm-hmm.
it will have its own intelligence. A Hive, it will decide whether job needs a map reduce or not. Right? Suppose if I write select, that I'll teach you in Hive. So I just see here if I'm writing select star from sample underscore 07, right? So let me, what will you limit 10, right? It's a 10 rows from the file, correct? It's not a job. It's only the query and output, right?
Mm-hmm.
Now I want to submit a job. What is job? Count is a job where you need a some map reduce. So I'm writing now
Mm-hmm.
select count of star from the table name. So here you don't see about the code and all the things. You just going to teach you about the job running in Hadoop cluster. Okay. So you forget about the syntax
Mm-hmm.
and programming. So don't think about that, because when we are in Hive, we talk about all these statements. Okay. So here my intention is to show you the jobs.
Mm-hmm.
Okay. Select the count of star from the sample underscore the table name. Now, so this job is taken by the, it's a map reduce job. Uh, means running in a yarn environment. Okay, see now the job ID. So this is the job ID. Okay, so
Mm-hmm.
now I submitted job now. You can see, you can observe here the job, right? The job
Yeah.
ID.
One
Right,
app.
right.
Mm-hmm.
Now refresh it. So who is monitoring the job now? The job is running. So who is monitoring the job? Application master.
Yep.
Correct? So job is
Mm-hmm.
running now. Right, job is running and the job is monitored by application master. Node manager is busy with the job. How much job is completed? If you place the mouse point on the progress, it will show you the percentage. Right, still the job completed now, succeeded. Right, so this is the application ID. It's a job ID or it's application ID, and this is job and the map reduce application, and by the user is
Mm-hmm.
the time, and the job state is finished and state is completed. Right, so you can see the number of rows. Right, 823 rows are there. Okay, so like this, now we can check the job status here,
Mm-hmm.
right? So if you click on the job name, so now you can see more details about the job, right? So this is how to check the jobs in a Hadoop.
Got it.
Suppose you can run a big program, something. I think already I have some program here. So user info. Now if I write dump to see the data, so it's one job now. So job is processed by the connecting to resource manager. Now just refresh it, right? You can see the second job. Okay, so it's a big program. Now
Mm-hmm.
who is pressing the job? So still job is assigning to the node manager. Yeah, right. It's given to the application master. He's monitoring the job. Okay, so 50% completed. Right, job is successful completed. Right, like this we can check all the jobs are running in a Hadoop cluster. Now we can see the number of jobs submitted. Right, so apps are running, apps are completed. Okay, so this is how to
Mhm.
check the jobs which are running in a Hadoop cluster. So this is how we have to check the jobs. Even if you submit a job, now we can check the status from the here. Okay, so that is a Yarn web UI. Right, any confusion, Amit?
No, no.
Right, now see here, but not everybody will flexible using this terminal. Right,
Yeah.
so in the newest environment I'm looking for GUI. then
Mhm.
then we have a hue. So what is a hue? Hue is a one component in Hive, in Hadoop, which provides the GUI. See, hue is a, see, we have the three types of Hadoops, right? One is a Cloudera, and other one is a,
Hortonworks.
yeah,
Hortonworks.
another one is a Hortonworks and Mapper, right? See, now we'll show you the Mapper. So Cloudera, which file system we are having? SDFS, okay? And then
Mhm.
can use both all the map rate as well yarn as well as Spark here. Okay, so data
Mhm.
storage, data processing, and GUI for the developers is a Hue. Okay, Hue is for
Mhm.
the GUI for the
Developer.
Hadoop developers, and Cloudera Manager is an admin tool for the admin GUI tool, Cloudera Manager. Okay,
Mhm.
so then coming to the Hortonworks, it's the same thing up to Yarn Spark. So actually, Hue is a Cloudera component. So if you put experience like 3 4 years in Hadoop, but in 2014, 2015, Hortonworks is also having Hue. Okay, Hortonworks is also having Hue as a GUI. But the
Okay.
thing is, your competitor is a Cloudera. Then your business opponent is a Cloudera, and you're using Cloudera's product in your business. Doesn't seems good, right? So
Yeah.
2015 onwards, in the newest versions, the Hortonworks comes with
Own something.
yeah, own something, that is Ambari. Okay.
Oh, Ambari.
Yeah, so this is Hadoop 2015 onwards in the Hortonworks for the developers, Ambari developer view and Ambari admin view. Okay, for the developers and admins. And coming to the mapper, it's completely different. For the file system, they don't use SDFS, they are using mapper file system. Okay, so now this R architecture doesn't work for the mapper, whatever I teach you till now. Okay,
Mhm.
so because they don't use SDFS, they use a mapper file system. And this is the same thing, map reduce yarn spark they use.
They also have something different.
They use a hue. Okay, for the
Okay, they
developer,
also use.
right?
Okay.
And for the admin, it's MCS, mapper control system for the admin activities. Okay, it's very and simple. If you see some screen
Mhm.
anything, generally all the time Cloudera will use a blue screen. If you see,
Oh.
right,
Mhm.
it's very easy to identify whether it belongs to Cloudera or Hotels Mapper. So if you see the Cloudera of any page, any documentation, it's always in the blue color. You can open any page, any program window or any screen window. So Cloudera is always in a blue color, right? And everything is blue. But if it is in Hortonworks, it's completely green. Okay, see, right?
Right.
But if you see the Hortonworks, So they use a green for everything. So now by looking a screen, I can tell you whether it's a Hardworks or the Cloudera because it's completely green. Right? Can you able to see the green?
Yeah.
Right? They use most green. Mapper they use a red. Every screen, every
So
document, every title is a red color.
everybody is using in a different way.
Yes. So it comes with experience. If I see the screen, immediately I'll tell you it
Mm.
belongs to which district because mapper always uses the red. See this.
Okay. Yeah.
Now you can able to identify any if you see any screen window in a
Mm-hmm.
documentation, we can easily tell you now if it is in red color in window. Suppose if you took the
Then
screenshot,
mapper.
right? If you took the screenshot kind of red color, think that they are using a mapper Hadoop, right? If you find a green color, it's a Hortonworks. If it's a blue color, it's a Cloudera. Okay, right? So this is the right. So when you're working in the Cloudera, the GUI is a hue. So now how to access this GUI? Now the same thing. Take the host name, uh,
And put the
8888. You have to
mm-hmm.
remember the numbers, right? So now host name colon right 8888. Now you see the GUI graphical user interface. Okay, so this is GUI screen where you can able to submit a job. Now it will be easy for you. Suppose you don't know much programming, you can
Mm-hmm.
start working from here, right? So if you write this Hive screen, okay,
Mm-hmm.
suppose it's a sample underscore 07. Now you can see the fields here, right? If you want to run a job, so some simple, you don't know the syntax or anything, it will help you. Press Control Enter, it will show you this help, right? I
Mm-hmm.
think you know the Toad, right?
Yep.
Yeah, the same kind of thing you can find here. We can also connect Toad to this Cloudera. It works. Select the count to start from the sample underscore 07. From here also we can run. That execute it. So now the job runs and it will give the output. Okay, so it's a GUI. Right now everything is available here. You can get Hive, Peak, Impala, HBase, Cube, Uzi, File Browser, Job, anything is available. Okay, so Hue.
Yep.
Okay, so the one which you're working
Yep.
is Cloudera. Generally, we don't we will have only the two things in your office. We use a putty
Mm-hmm.
and this browser. That's it.
Yeah.
Okay, fine.
Mm-hmm.
Any other
Yep.
questions, Amit?
No, as of now, no.
Right. So you just go through this one's revision, uh, and in the next session, what I'm going to teach you, Hadoop file system. Right. So we learn these three things.
Okay.
Right. So what we completed now? We completed this one.
Hadoop Agent Demo. Hadoop Tester.
Okay, so I'll teach you in the next session Hadoop file system,
Okay.
like creating the files and accessing the files from the HDFS file system, and what are the different ways to load the data to the Hadoop cluster, and Hadoop configuration files. Okay, fine. So can I
Yeah.
end now, Amit?
Yeah. Yeah. That's yeah.
Yeah. Okay.
So and can you share this video and this one?
Yes. It generally
Yeah.
wait. Give me some time. It takes.
Okay. Yeah. 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 Yeah.
Yeah.
Yeah. That's fine. Yeah. No problem.
Yeah.
That's fine.
Because it takes time. Because
Oh.
I have to convert this to MP4 format.
Oh.
Right.
Okay.
Generally, the video comes to this format.
Okay. Okay.
Okay.
Okay. No problem.
Right.
Okay.
It's a
That's fine.
very big
Okay.
file, so it takes hours of the time to convert into MP4. After
Oh.
that,
Okay.
I need to upload.
Okay. Okay. That's fine. Okay. Okay. Yeah. Yeah.
Yeah. Okay, Amit, I'm coming to the next session. I'll give a mail after some time. So if I'm available evening, I'll also take this. Are you going anywhere at home today?
Actually, today I will travel actually.
Yeah.
So, but
Okay.
in the evening, so that's why I didn't tell you to schedule classes in Sunday.
Yeah. Okay. No problem. So we can
So,
connect tomorrow then. Okay. So same time, Monday.
yeah, so tomorrow will be Sunday, right?
Yes. You
So
available?
Sunday I will, yeah, no, Sunday I will be not be available.
Yeah. Okay. No problem. So just give me a mail.
So,
So whenever
but yeah, but in the evening I will be available.
today.
So yeah, evening by 7 or 8.
Yeah. Okay. Fine.
So in the night I have is 10:30. I will go in the night train. So
So today at night you travel, right?
yeah, in night, yeah.
Yeah. Okay. No problem. So if you're after 2 3 hours, you also available today.
Yeah, in the evening time, yeah.
Yeah.
For
Okay.
yeah, 1.5 hour, yeah, it will be available. Yeah.
Yeah, fine. So anyway, right? So I'll give a text in Google after 1 hour. So then
Yeah. Yeah.
let me
Uh,
fix my time today, and we'll have a session.
so in the evening time will be like 7 to 8 or 8 to 9. Is that possible?
That's a reason. I
Evening.
cannot tell you what that right now. So just give me some time. So actually, I didn't
Hmm.
plan anything today. So I wake up, I get ready, and I started training to you. So we'll decide in 1 hour, and I'll give a mail.
Okay. Okay.
Yeah, we'll
Okay.
discuss in Go
So
Hangout. Then we'll connect.
okay. Yeah. Okay. Because at this after half an hour I will go for some other stuff. So
Okay.
okay. So okay.
No, no
So
problem.
probably
We
that.
decide after
Okay.
1. I'll give a message at
Hmm.
12:30. Just we'll
Okay.
see hang out. Okay.
Okay. Okay. Okay. No problem. Okay.
Yeah.
Okay. Thank you.
Yeah. Fine.
Okay. Bye.
Bye.
Bye.